Boom, what's up everybody? Now we're going to relate this exponent stuff and the logarithms eventually to a real life, and there's lots of good ways to do that now. Got a couple simple analogies to make here. If a town has 1,000 people, each year it gains 50 people. So at the year zero means the beginning amount, that's 1,000. Then it gains 50, 1,050, gains 50, 1,100. 1,150, 1,200, 1,250. Okay, so if I had to find out how much you gained after 5 years, what I would do is I start at 1,000. We're always adding 50. And repeated addition, I was repeatedly adding 50 5 different times. Repeated addition, you times by 5. Okay. That's going to be 1,250. And also that's when we gain, when in the rate of change, back in first semester, if the rate of change was constant, we were always using that line, okay? 1,000 to start with, plus mx, but m is the rate of change. We were always adding 50. X means I'm adding it by that many years, and y. Okay, now the game's going to change, because we have 1,000 people, each year 2% increase. Now, does this make any sense? 1,000 people plus 2%. No, it doesn't. Those aren't like terms. That's people, that's percent. You can't add those. That makes no sense. So we have 1,000 people, and what I'm going to do with percents, okay, usually we times, okay? But what I'm going to do, since it's a 2% increase, I'm going to times by not just 2%, I'm going to take 100%, because those people are staying in town, and then 2% are joining them. So 102%, which is 1.02. So if I times that thing by 1,000 times 1.02, and that's going to be 1,020. Okay, now there's another 2% increase, so just repeat the multiplication by 1.02. Now I'm at 1,040 people. Times 1.02. Okay, that's going to be 1,061 people. Times 1.02. Okay, so that's after year 0. So 1,061 times 1.02. Now I'm at 1,082 people. Now, at this point in time, you recognize, okay, I'm going up, but the amounts I'm going up by eventually changes, okay? Therefore, this is not linear growth, okay? This is what you call exponential growth. And it doesn't go in a line. It's a curve, okay? Because you'll go up. Everywhere on that curve is going up from one point to another. They just go up by different amounts. They start going up by small amounts, but then as the years move on, when you get into like 50 years out, you're going to be really moving up by people, okay? So it's a curve. Now, to write this, solve it more efficiently, we have 1,000 people, and every time I was multiplying, not adding, like I was on this one, okay? I was multiplying by 1.02. Now, how many times was the multiplication repeated? It was repeated 5 different times to get to the 5th year, okay? So repeated multiplication, you don't just write times 5, okay? We've already used the times here. It's kind of like over here I plus, but then repeated addition, we use times. Now, repeated multiplication, you use an exponent. Okay, and it was 5 times. So 1,000 times 1.02 repeated 5 times is 1,104. Okay, because if you times by 1.02 again, that's what you're going to get. Okay, now let's solve some problems with that after that explanation. There is a way to set them up. I'm going to go over 4 of them on this packet. Okay, the owner of an original copy of a comic book sold it at an auction in the year 2005. The owner bought the book in 1980 for $55. The value of the comic book increased at a rate of 3% each year. How much should the comic book be sold for? So I'm finding how much we should sell it for. And there are 2 key units, dollars and years. So it's X and that's Y. So the dollars per year, we don't have a dollars per year. We just have, it says it's 3% per year. So cross out your dollars and put a percent, and it's 3% and put an up arrow because you know it's going 3% up. Okay, so when it's growth by not a money amount but a percent amount, we are going to make a curve, okay, like that. And here's how you set up a curve. You're going to go X comma Y like you do on a line, but instead of plus, it's going to be times. And instead of mx, what I want you to put is g to the power of x. G stands for growth factor. It's not a m, so it's not a slope. And then y up here. So that's the setup. And the setup's actually easy. Your Y is money, so we know that our money amount starts, the comic book starts, it's $55. Now my growth factor, how do I find a growth factor? I always take 100%, and then I add or subtract, depending on what it's doing. Add on this one because it's going up, so I add 3%. That's going to be 103%. So when I put this in my growth factor, though, I need to write that as 1.03. Okay. So now I can write my equation. I have $55. I will be multiplying that by 1.03 to the x power a certain number of times to get a new money amount, which is y. Okay, so what else do we have? Well, we know the number of years. Do we know the number of years? Because X is years. It'd be nice if I could put something in for that. And I do know the number of years because I know it spans from 1980 to 2005. So I can take 2005 minus 1980. That's a time span of 25 years. So I know this went on for 25 years. So I can just punch it into my calculator. 55 times 1.03 to the 25th power. That's $115. Okay, my next one. You put $125 in a savings account that earns 2% interest each year. You make no deposits or withdrawals. How much will our investment be worth in 10 years? We got money in years. X is years, Y is money, and the dollars per year I don't know. I have a percent per year, so it's 2%. Interest makes your bank account go up. So again, a percent means we have not linear growth, but it's exponential growth. So I have X comma Y times, not plus, G to the power of X equals Y. Okay, so our money started at $125. You cross that out. And then your growth factor, you take 100%, add your 2% in there. That's 102%. So cross that out. That's 1.02. That's your growth factor. So now I'm in a good position to write out the equation. 125 times 1.02 to the x power equals our new money amount of y. Okay, so I have 10 years. Well, years is an x value, so it goes in for 10. Last year, all we did was put numbers in for the x in these problems. You are going to learn how to put numbers in for y and solve for x in the next video. Okay, so $152.37. Just round to the nearest dollar when you're doing this. Okay, in 2004, a person purchased a car for $25,000. The value of the car decreased by 14% annually. Calculate the car's value in the year 2012. Okay, so I need to find the value. So I've got money and years. So X is years, Y is money. So per dollars per year. And that's going to be 14%. Annually means per year, but this time it decreases. So it's actually called a decay factor, but I still want to use G. Okay. Times G to the power of X equals Y. You're not going to use M. So we know what happened. Well, we started with $25,000. Then we start timesing by our growth factor, which is 100, but this time we're going to minus 14%, 86%. Now it's less than 100%, so you're going to write 0.86. So we have 25,000 times 0.86 to the X power equals Y. Got that, and then years. Find the time span. 2012 minus 2004 is 8. Okay, so 8 years, bro. So 25,000 times 0.86 to the power of 8, and that gives me my answer, 7,840. Okay, now there are 128 teams at the start of a citywide 3-on-3 basketball tournament. Somebody could do this without setting all this crap up. Half the teams are eliminated each round. How many teams are left at the beginning of the fourth round? All you do after round 1, cut it in half, you're at 64. Cut it in half again, you're at 32. Cut it in half again, you're at 16. So 16 is the answer, but let me show how you could use this to get 16. Half means 50%. So the units would be teams and rounds. Rounds is the X, teams would be the Y, because rounds is like your time. So teams per round, I know half of them, so 15%, because they change from round to round. It's different amounts, so that's why they call it a percent. But they're eliminated, so it's down. So X comma Y times G to the X power and Y. Okay, we have 128 teams at the beginning, and I take 100% minus 50%. That's 50%, so that's 0.50, or 0.5 means the same thing. So I have 128 times 0.50 to the X power equals Y. Okay, and we know that round 4 hasn't been played yet. At the beginning of round 4, there have been 3 rounds played. So we don't put 4 in for X because we haven't completed the 4th round. We've completed the 3rd round. So 128 times 0.50 to the power of 3. I got 16 just like I did in my head. Okay.